remarkably, the full moon appears every month in our sky, a sight so familiar that we often take it for granted.
But about twice a year, over the course of a few hours, the full moon sports.
Hello. Good afternoon. Are you able to hear my voice?
Yes, sir.
Yes, sir.
Also to see the screen. Screen you can able to see now?
Yes, sir.
Oh, okay. No. Just I told that yesterday we will discuss about the eclipse part because one of the planetary phenomena. Then we will see that what best we can do it. Just you watch it for a few seconds. I will repeat.
A decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth every month as it. So why don't eclipses tilted relative to the Earth's orbit? They rarely shade at all. Throughout the year, twice a year, this Earth's shadow here. You have to stay up late to watch.
In the previous video, we talked about the phases of the moon and how that relates to the moon's orbit around the Earth. It might be helpful to watch that video first. To put things in perspective, here's the relative size of the Sun, the Moon, and the Earth. The Sun is about 400 times bigger than the Moon. Now let's look at the actual distances between them. The Sun is also about 400 times further from the Earth than the Moon is. This is why the Sun and the Moon appear to be about the same.
Okay, now we'll stop for a while. 5 of you are there. Kindly let me brief what you mean by a solar eclipse. Not the meaning of that one. Some information which can enlighten you or something which attracted you to study. What shall I do? Okay, maybe we'll start with Naresh Babu.
Yes, sir.
Yeah, please. Just tell us that what you understood by solar eclipse. Not be for today's, whichever may be the solar eclipse which was happened so far, or whatever you learned out of it.
When Earth, Sun, Moon all come together, all come in one straight line, the eclipse will occur.
Okay.
When Moon comes in between Sun and Earth, it will be lunar eclipse.
If Moon disappears,
It will be solar eclipse.
wow. If Earth disappears,
Sir, we are on Earth, sir. How can we see that?
or if Sun disappears, can Sun see something shadow which falls on something else? Can you expect shadow of Moon on Earth? Shadow of Moon on Earth? Yes or no?
No, sir.
No. Okay. Can you expect the shadow of Earth on Moon?
Yes, sir.
Can you
Yes, sir. We
expect?
can
Can you expect the shadow of Sun on either Moon or Earth?
shadow of Sun. No, I think.
What?
No, we cannot see. We cannot see
When I
shadow
see
of
it,
Sun.
we can't say.
We
Others?
can't say, sir.
Is it Earth? See, if some light falls on some obstacles wherever, can you expect the shadow of any of the objects on Earth? Why not? If you lift your mobile and let it be in light from the top, you can have the shadow of the mobile at the bottom, or maybe wherever you are in the opposite direction of that light. Okay. If that is the case, if there is a light falls on moon, can you expect that the shadow of moon on Earth?
Yes, sir, we can expect.
Okay. Can you expect that shadow of Earth on moon?
Yes, sir.
Shadow of sun?
That we can't say, sir.
Can you expect shadow of either Earth or moon on sun? Some other bright element will come from outside. It should be brighter than sun. If the Earth is coming in between, can you expect that shadow will fall on it?
If it is more brighter than sun, we can expect.
Okay. Okay, no problem. Just think it out. Here, sorry, where it is there? This is the video what we are telecasting, not that is not required. Here, just observe.
The same size in the video, we talked about the phases of the in the previous video, we talked about the phases of the moon and how that relates to the moon's orbit around the Earth. It might be helpful to watch that.
Wait. Yeah, let it be this first.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow.
I'll stop here. The earlier case, what they told actually, sunlight falls on Earth and falls on the moon is one kind of a lunar eclipse. Fine. If not,
Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both.
moon circles around the Earth every month. Okay, means if that is the case, it has to obstacle on each day. Why can't we get 28 eclipse? Any answer? Vaida Banu, she is there. Ayesha, oh, she is there. Then Vaida Banu is not there. Sorry, Shalini, Shekhar, Suma, Arpita, Shushmita, and then Vijay Lakshmi. Anybody can answer. Moon revolves around the Earth. This is the light ray which is coming in. Okay, assume that if moon goes here, moon will be the obstacle where light should not fall on the Earth. Or if that is the case, because of the moon disappears. Moon disappears. You may be having, you can see the moon actually, but sometimes it gets disturbed. Actually, moon disappears. Actually, you may not able to see the moon at all. Sorry, you may not able to see the sun at all. Then solar eclipse you can call. At the same time, if the moon comes on the rear end here, certainly you can see the moon here. When it comes in between, when the Earth comes between the sun and the moon, actually moon disappears. Is it happening every day? But you are keeping silent. Yeah? Can you able to hear my voice?
Yes, sir.
Yeah. Okay, or just watch. Doesn't matter. We'll see
Both
that.
full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun.
It is tilted by
Although
5
the
degrees.
Earth and the moon always cast long shadows,
that-
they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watch the eclipse from Earth's atmosphere,
sunlight gets abstracted, sunlight gets diffracted or maybe scattered because of the Earth's atmosphere. The color of the moon may be the whitish 10:20 at some time, maybe 11:30 at some other time. This may be mainly because of the existence of the atmospheric constituents like nitrogen, oxygen, argon. Apart from that, the dust particles, aerosols they can call actually. Those particles along with their size distribution makes them some kind of a light should be reflected towards the earth, some kind of a light should be scattered away from the earth. Of course, you can call the phenomena as reflection also, but if it goes back to the same system, it is reflection, same media. If it goes from one media to another media, is refraction. If it gets scattered, scattering is a phenomenon in such a way that where the light should be absorbed first, then it should be scattered back to its environment there. That they can call it as the scattering phenomena of that kind. Color of the moon is mainly like blue moon, maybe reddish moon, or maybe a pink moon, or maybe what they can call Champu Chandra, Raktavarna Chandra, whatever they call in different languages actually, that is mainly by the atmosphere, not by the moon alone actually, moon alone. Of course, if moon possesses the atmosphere, certainly some portion of the scattering will happen because of the atmosphere of the moon. Let us see here again.
In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow.
See that the moon, if you're watching from the moon, the color of the sun, if you're watching the eclipse from the moon and where the Earth comes in between, you can see the color of the Earth's atmosphere as a reddish color.
Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
This is the beam of the satellite. Let us see next. How it will happen, you can see in detail. Don't worry with the advertisement in between.
In the previous video, we talked about the phases of the moon and how that relates to the moon's orbit around the Earth. It might be helpful to watch that video first. To put things in perspective, here's the relative size of the sun, the moon.
See that? Relative size of the sun, relative size of the moon, and relative size of the Earth, and the distance of separation. In terms of size, Praveen is there. Praveen. He missed it today. Okay. Just check actually.
Moon and the Earth.
Moon is smaller.
The sun is about 400 times bigger than the moon.
You note down. Sun is about 400 times bigger than the moon. You note down for the size of the sun is 400 times the size of moon. Means what you have to say that the size means dimension, you can call dimension of sun must be equal to 400 times the dimension of the moon.
Now let's look at the actual distances between them.
Let us see the distance of separation.
The sun is also about 400 times further from the Earth than the moon.
Distance of sun is also about 400 times farther from the Earth than the moon. Means distance of sun is equal to 400 times the distance of moon. Means, for example, the distance of moon is 1, the distance of sun is 400 times. If distance of moon is 1, then distance of sun is 400 times. Distance of the moon is 4 lakh kilometer, okay, roughly. What must be the distance of the sun from the Earth? Answer from your side.
4 lakh into 400.
4 lakh into 4, how much?
400 times.
Right.
1.5 billion, sir.
Huh?
1.5 million.
1.6 it will come actually. 400 into 4 is 1.6 lakh 160 million kilometer. 160 million kilometer. If it is about 3,80,000 kilometer, I will open the calculator. Doesn't matter. Calculator here for you to help. 4 into 400 becomes 1,600. If 4 into 3.84 kilometer you can get. This is 15, 1.536. This is the 153 million kilometer is the distance of the sun from the earth. Okay. And in terms of the dimension, they can call dimension of the moon, we have not noticed. Dimension of the sun also we have not noticed. Assume that what must be the dimension of the sun. For example, dimension of the sun is 0.7, what you call 1.4 million kilometer. 1.4 million kilometer. 140, 1, 2, 3. Fine. Yeah, this is so many million kilometer. Divided by 400 if you make. Okay, 3,50,000. 3,500 kilometer is the dimension of the 3,500 kilometer is the dimension of the moon, whereas 140,000 kilometer is the dimension of the sun. This dimension of earth is about roughly 13,000 kilometer. 13,000 kilometer. Remember, the dimensions of moon is 3,500 kilometer. Dimension of earth is 13,000 kilometer. Dimension of what we can call sun is 1.4 million kilometer. They can call 1.4 million kilometer or 14 lakh kilometer. They can call. Means if you take 1,400, 1.4 million kilometer divided by 13,000 kilometer. If you take 13,000 kilometer, you can take. What must be the case? About 1,000 times should be 1,000 times. It should be more than the dimension of not 1,000. It should be 100 actually. It should be 107 or 108. I missed 10. 180 times. 180 times they can call. 14 million kilometer. 1.4. This is 40. This is 3 plus 3. 10 should be come down. Yeah, 1.4 million kilometer divided by 13,000 kilometer. It comes to be roughly 107 or 108. 108. Okay, this number you remember. This comes to be 108. Okay, and 13,000 kilometer divided by 3,500 kilometer for the 3,500 kilometer for 3,500 kilometer the sun. Almost 4 times. 4 times. Okay, 4 times. 4 times. This you remember. Then let us see the video.
This is why the sun and the moon appear to be about the same size in the sky. Now you know that the
sun and moon appears to be the same size in the sky. Otherwise, how can you see that if the moon comes in between, entire moon should block the size of the sun actually. Sun is compared to the moon, sun is about 400 times more. 400 times more is where you are bringing moon, very short object in between earth and the sun in such a way where it has to completely block the entire radiation which is coming from the sun. Just check.
Animations on screen are not always drawn to scale.
You can't draw onto the scale.
The moon's orbit is actually not a perfect circle. It's in the shape of an ellipse. When it's closest to the earth, we call it perigee.
When it is closest to the earth, actually, it is called perigee. Perigee's distance is about 396 kilometer, almost 3.63 lakh kilometer perigee. I will go proceed.
When it's farthest away from the earth, we call it apogee.
When it is farthest away, okay, it should be about 40504 kilometer. Okay, the average distance we are taking about 3.8.
It's only a small difference, but it's enough to cause the moon to grow and shrink as seen from the Earth. Okay, now we get into some rare events with the moon.
Intensity will vary.
Each time a new moon happens, there's a chance that the moon will block the sunlight and cause a shadow to
see that between Earth and the moon, between the Earth and the sun, moon is coming.
Appear on a portion of the Earth. When this happens, it's called a solar eclipse.
It is called solar eclipse. Length of the solar eclipse, how long it can go? Anyone? How long it can go? Who is there? Oh, all are there. Shalini? Few minutes, few seconds, few hours, few days. Of course, it should not go more than 12 hours. How long? Maximum it can go about 6 to 7 minutes. Somebody is talking. 6 to 7 minutes is the length of the solar eclipse of the penumbra. But the lunar eclipse, it can put a shadow to the extent of 110 minutes was the longest duration what it was observed so far. But roughly about same case, 100 minutes to 2 hours of that kind, longest one.
The reverse can also happen.
Reverse can
Each
also
time
happen.
we have a
See that.
full moon, there's a chance that the Earth will block
Earth blocks the incoming radiation.
the sunlight
It will
from
fall on
reaching the moon. We call
Shadow
this a
of
lunar
Earth on moon disappears is lunar eclipse. If the moon comes in between Earth and sun, where sun disappears is the solar eclipse. Whoever is disappearing is that eclipse. Can Earth also become eclipse? Lunar eclipse, solar eclipse. Earth eclipse is there. Earth should disappear. Think of.
lunar eclipse. So now the question is, why don't we get a solar eclipse and a lunar eclipse every month?
See the
As the
geometry?
Earth orbits around the sun, we can map out a 2D plane that's referred to as the ecliptic. The moon doesn't orbit on the same plane. It's tilted by about 5 degrees. This means that most of the time, the moon passes above or below the sun as seen from
Sorry, can you able to see that? Yeah. Most of the time, either the moon can go either below the Earth plane or it can go above the Earth plane. If it is at two places, certainly it can have the eclipse.
moon passes above or below the sun as
See that.
seen from the Earth.
See here.
We
right
can map
here.
out 2 invisible points in space at which the moon's orbit crosses the ecliptic.
Yeah, at two places.
We
certainly
call
it will
these the
interact.
lunar nodes.
See that moon is here.
When they line up with
Sun
the
is on
sun,
other side.
Earth, and moon, that's when a solar eclipse or
Yeah,
lunar
fine,
eclipse
good.
will occur.
There, see, moon is there between the Earth and the sun. Moon is there. One eclipse is known as the solar eclipse. If the
This
same
is
thing
referred
goes
to
back,
as an eclipse season. These happen about twice a year. During an eclipse season,
Sure.
there's no
I got it.
guarantee
The
that you'll
same
be
thing.
able to see anything. In the case of a solar eclipse, the moon may pass slightly above
the moon may cross above the Earth.
or below the sun and give us a partial solar eclipse.
See that. See that.
This won't really dim the
These cases you
sunlight of the
remember.
sun.
Sometimes
and
it may
in the
go,
case of a solar
moon can
eclipse,
go
the
little
moon
bit
may
up,
pass slightly
partial
above
solar eclipse
or below the
from
sun
the top,
and give us a partial solar
again
eclipse.
partial from the bottom.
This won't really dim the sunlight enough for us to
If
see
they
it.
come in with exactly the
When the moon entirely crosses the sun, we will be able to see it. If the moon is closer to
My
apogee,
God. This part.
if the moon is closer to apogee, then it will appear smaller and we'll get what's called an annular solar eclipse.
See that. This is the annual. If it is in the
If the
apogee,
moon is closer to perigee, then it will appear bigger and we'll get what's called a total solar eclipse.
Can you got the idea?
Even if you're
Total
lucky
solar eclipse
enough
is
to be on the
there,
right
I'll repeat.
solar eclipse, then it will appear bigger and we'll get what's called a total solar eclipse. Even if you're lucky enough to be on the right spot on the Earth, the longest you'll be able to see a solar eclipse is about,
repeat.
and we'll get what's called a total solar eclipse.
When total solar eclipse comes actually, whether apogee or perigee. Okay. If it
Appear
is at
bigger,
perigee,
and we'll get what's called a total solar eclipse. Even if you're lucky enough to be on the right spot on the Earth, the longest you'll be able to see a solar eclipse is about 7 minutes.
7 minutes is the
You'll
maximum
need to be
time.
under the umbra, which is
Yeah.
the darkest part of the moon's shadow. For a lunar eclipse, the Earth is the one casting the shadow. We may see a partial lunar eclipse
Full lunar eclipse,
or a
partial.
total lunar eclipse.
See that.
This can be
Because
seen
entire
from
Earth can
anywhere on
block,
Earth
because
where
the
it's
dimension of
night
the Earth is
and will
quite
last for
larger.
several hours. For about an hour, the moon will appear red
about an hour?
because of the sunlight bending around the Earth. This is where the term blood moon comes from.
Here, what it says that for blood moon?
This is where the term blood moon comes from.
Still you go back.
Sunlight bending around the Earth. This is where the term blood moon comes from.
If sunlight
around the
bends
Earth.
around the Earth,
This is where the term
for total
blood
solar
moon comes
eclipse,
from.
lunar eclipse only it will happen.
So next time someone says the words solar eclipse or lunar eclipse, you could explain it to them, or you could just send them a link to this video.
A solar eclipse happens or all of the sun's rays from reaching the Earth.
Sure.
By cosmic chance, even though the sun is 400 times wider than the moon, it's also 400
Remember, 400 times farther away from the moon. This is 93 million kilometers. This is about 239 miles.
times farther away. Therefore, the two objects appear the same size in our sky.
Two objects appear in the same size in the sky. Both Earth and Moon are the same thing. It is an angular separation, where you can expect the shadow here due to the shadow is mainly because the moon has obstructed.
Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits.
It is a repeatable orbit.
Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth. A smaller, darker shadow
Only very small
known as
because the size of the Earth is size of the Moon is less, and it can't go blocking entire Earth.
the umbra,
This is umbra part.
and a larger shadow known
Sometimes
as
it will fall like this. Okay, penumbra.
the penumbra. There are four types of solar eclipses. The first and most spectacular is a total eclipse.
This is a total solar
when the
eclipse,
moon
what we are
completely
getting today.
covers the sun's surface. A total eclipse can only be
Sure,
seen
sure,
if you're
sure.
standing within the
My
umbral
God.
shadow. That's why the imaginary line created by this shadow as it races across
the path
Earth
of
is
total
known
solar
as the
eclipse.
path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the moon passes in front of the sun off-center, never fully covering its surface. Third, an annular eclipse occurs when the moon passes directly in front of the sun. However, unlike a total eclipse,
This is the ring of fire, they can call.
the moon appears too small to fully cover the sun. The moon's orbit is elliptical, so sometimes it's closer to Earth and sometimes it's farther away. Last, a hybrid eclipse is when the moon's position between the Earth and sun is so finely balanced that the curvature of the Earth plays a role. The moon will be farther away from some parts of Earth along the eclipse's path, resulting in an annular eclipse.
This is
In other parts, the moon will be just close enough to fully cover the sun, resulting in a total eclipse. While a total solar eclipse happens somewhere on Earth every year or two, any given point on Earth experiences the event
is the
only
time of
about
occurrence of the
once
eclipses.
every 400 years. We interrupt this video for an important safety announcement. Permanent eye damage is to use certain times darker than. Simply poke a small sun's cardboard. Hold the cardboard up to the sun.
This may be a pin
Be
in
sure
whole camera.
just before the moon completely covers the
See, sir?
sun, low-lying valleys on the moon pass through. These beads, a single bead of light remains, known as the diamond ring,
This is known as a
signaling that
diamond
you're
ring.
just seconds away from
Looks like
experiencing
diamond.
totality. Once the last bead disappears and the moon completely covers the sun's surface,
When it completely
the
covers
view
the sun,
through your
actually,
eclipse
one has to
glasses
see
will be
that how
pitch
that
black.
images can happen.
Totality achieved.
Madam, photo any button, class.
At this point, none of the sun's rays are reaching your eyes, and it's the only time that it's safe to take off your glasses before we
Okay, let
Look,
us see
man,
here.
I just want my sales back. Nobody's buying nothing these days. How do I find new clients?
See that?
Look what working from home did to me. I'm a mess. How are you supposed to balance your home?
This we have seen.
Hundreds of years ago, a war broke out near present-day Turkey and the Halys River. The two warring sides were the Lydians and the Medes. The war raged for 5
On March 20th, 2015, the shadow of the moon will
It was
cross
an
the
earlier
surface of
video,
the Earth.
no issue. Let us see that how that best can be there as a live. This is the dimension. If we see that actually how that Earth is moving with the Earth, the satellites which are revolving close to that 4 o'clock 56 minutes 28. Sorry, it has not reached 2 o'clock. Yeah, 3 o'clock 34 minutes 19 seconds. See that? See here. This is the same thing. Still. This is the position. Yeah, sun is here, Earth is here. Where is the moon? Now we have to identify the moon. They have to come in between. See the moon. How slow it's moving. Hubble telescope is there. Sentinel Michael French is there. TESS is there. Pluto somewhere here. Saturn comes. Lunar Reconnaissance Orbiter is orbiting. Jupiter comes in between. Where the Earth has to come right now. Neptune, far away here. Earth, moon. Where is the position of the sun? You have to see that. Okay. Here they will go with some live program.
See today, but if the clouds hold,
this I told. I don't know. Here, this is for Canada. Assume that if I search for Bangalore is here, not visible in this location. 25th partial solar eclipse. Okay. Even you can pin. Depending on pin also you can do that. With reference to that, if you go for any of the areas, entire Earth, see, go up, still. Yeah, see, this is the shadow. This is the last path. Maybe the possibility where it may not come. Maybe over China it will be there. Only few portion of it. Here, if it's still, maybe still more. This red color, dark red color, wherever you are looking, that will be the umbra. 100% annular eclipse. You can expect the people who are staying here can see here. Here you can see that. Of course, this is not the place. This is the only few part actually. Okay. If you go here, see that here again. Maybe if you come here, again here, like that, how it has to go. And a 3D globe, if you grow, see that this is the region. This is the region actually where the people can see the totality actually. Except other part you can't, because that is the moon is little bit below and the shadow goes from bottom top to the polar region. Where is the India? India somewhere here. Yeah, India is somewhere here. Not somewhere here, exactly here actually. India is some point, because this pinpoint is shifted. Okay. See animation how it works. See that moon is at another end. What happened? Yeah, coming. Moon is some moon disk actually. Moon disk falls onto the sun and shadow has to fall. See that after coming here, it is not making tilting. Can you get the idea? It's going down. That's why I can't. If I choose this point, see that, oh, you are getting dark. Now it is tilting. Why it's happening? That's why you are getting the circle for only for the northern hemisphere. Okay, just on 3D globe, you interact here, you can see that how it should be looked into that. The same case, this is for 10 June only. Here what they will explain. See, this is for the Great American Eclipse. Same thing with their timings, they are showing that. Blocks. This is the path for United States of America. See that. Particularly wherever it goes, it can be seen here. Only few parts of here. Okay. This is the totality. This is the totality. If you go with live stream, they will also give the explanation. Just we'll check. Live stream not yet started for them. It will come back. See from the top how it looks. The small dot is the eclipse part of it. According to UTC, they have put see here. This is almost 19 UTC. 19 minus 530 you can go. 19 minus 5 is 14. 1330. 1330 means 330. Direction is about 270 degree, magnitude is about 0.4, minus 0.4. This is from Australia, they are showing. Can you see the solar eclipse during night time? But if there are clouds, means set of tasks. See, now partial. See, like that it will continue. See now, this is the actual from Canada, Ontario place. See that. This is a picture taken from very good telescopes. This is Perth, Australia. The time is going up. In that you watch.
Long years, but in its 60th, in the middle of the day, the sun, from out of nowhere, disappeared from the sky, plunging everything into darkness.
Sun disappears, no photosynthesis.
This was interpreted by both sides as divine intervention to halt the ongoing war. Herodotus, an ancient Greek historian, writes in one of his works, "Just as the battle was growing warm, the day suddenly changed into night. The Medes and Lydians, when they observed the change, ceased fighting and were alike anxious to have terms of peace agreed on."
Because
In order to
birds and
heed
other
the
things
gods' word,
go to nest
both sides called for
leaving
a
us.
truce, which was further cemented by a special marriage. The daughter of the king of Lydia was married to the son of the king of Medes. Thus, in the end, it turned out to be a happy ending for the warring parties. However, what both sides didn't realize was that the sign from the skies that stopped their war was a perfectly natural celestial phenomenon, a total solar eclipse. NASA validated the story.
For just $67, you can make as many videos as you want, and you never need to pick up a camera or
Their estimation, based on solar eclipse data, is that a solar eclipse is likely to have passed over the area where the Lydians fought the Medes on May 28, 584 BC. In this case, a total solar eclipse. Exactly does a solar eclipse happen? Earth travels around the Sun along that orbit and completes one revolution in approximately 365 days and 6 hours. As you may have noticed, this is roughly the length of 1 year. So, does that mean Earth is at exactly the same spot in its orbit every year on your birthday? Well, since it takes the same amount of time every year to complete one revolution around the Sun, it's only fair to assume that on your birthday, Earth will be in exactly the same spot every year. We've actually answered that question in another video that you can watch by clicking on the I button at the top right corner of the screen. Just as Earth moves around the Sun in an elliptical orbit every year, our natural satellite, the Moon, also revolves around the Earth. It takes about 27.322 days for the Moon to complete one revolution around our planet. So, Earth revolves around the Sun, and the Moon revolves around Earth. Pretty neat, right? Due to all the interrelated motion happening between these three celestial bodies, several physical phenomena occur. When the new moon, during its revolution around the Earth, moves between the Sun and the Earth, it blocks out the Sun's rays, which casts a shadow on parts of the planet. This is called an eclipse of the Sun, or a solar eclipse. In other words, A solar eclipse happens when the moon passes in a direct line between the sun and the Earth. Now, you may be thinking that the moon is infinitesimally small compared to the sun, so why is it ever able to cover part or sometimes even the entire sun? Although the moon is indeed about 400 times smaller than the sun, it also happens to be around 400 times closer to us than the sun. This is why both the moon and the sun appear to be the same size in our sky. The moon is very small compared to the sun and to the Earth, which is why the moon's shadow isn't big enough to engulf our entire planet. Therefore, the moon's shadow is always limited to a certain area. This area changes even during an eclipse, as both the celestial bodies are in constant motion with respect to one another. When the moon eclipses the sun, it casts two types of shadows on Earth. The first is the umbra, which is a small and very dark shadow. If you're in a place on Earth where umbra is cast, the entire central portion of the sun will be blocked out from your perspective. The second type of shadow is known as the penumbra. It is a larger and relatively lighter shadow than the umbra. If the penumbra passes over you, then only a small part of the sun will be blocked out from your point of view. Depending on the type of shadow the moon casts on Earth, solar eclipses are broadly classified into four types. The first is a total solar eclipse. This is the most spectacular of all eclipses because, during a total solar eclipse, the entire sun is completely blocked out by the moon. This can only happen when the moon is near perigee, the point of the moon's orbit when it is closest to the Earth. You can only see a total solar eclipse if you're standing within the umbral shadow.
And I'm
Since the
Graham
Earth keeps
Jones.
rotating, the
Thank you
umbral
for
shadow
joining
doesn't
us.
stay at one point on Earth, it keeps moving too. The imaginary
Well,
line
Anna,
created by the
today
umbral shadow is
we
known
are
as
in
the path
for
of totality.
potentially
If you're in any of the
the
places
most
through which this imaginary line passes,
anticipated
you can see when the sun gets completely blocked out by the moon. Next up is a partial solar eclipse. This type of eclipse is observed when the moon covers only a part of the sun and casts a penumbra on Earth. Since it only covers a part of the sun, this phenomena is known as a partial solar eclipse. When the moon passes through the center of the sun, but its disk isn't big enough to cover the entire disk of the sun, then an annular solar eclipse occurs. When this happens, the sun's outer edge will completely block out the sun. Some parts of the Earth witness an annular solar eclipse, the sun and the Earth, while at other times it goes behind the Earth, so that the Earth comes between the moon and the sun. When the latter happens, we see a lunar eclipse. The moon completes on its axis, when it is perfectly aligned so that the moon falls red. This happens due to refracted inward towards the moon. The shorter blue wavelengths of sunlight are scattered. The moon loses its under the umbral shadow of our planet. During a total eclipse, Earth completely blocks any sunlight from reaching the moon. Due to this, the moon loses its characteristic whitish-gray color and becomes a sunset red. This happens due to refraction from the Earth's atmosphere. The shorter blue wavelengths of sunlight are scattered outward by the atmosphere, while the longer red wavelengths are refracted inward towards the moon, giving it a reddish tinge during a total lunar eclipse. Next is a partial lunar eclipse, which happens when the moon, Earth, and you can see Earth's shadow passes through Earth's penumbral shadow. This celestial event is so subtle that many of us don't even notice it visually, as the moon appears only slightly dark. You can watch a lunar eclipse if, in contrast, the Earth consists of a broad range of radiation, from ultraviolet radiation, and a considerable portion of this radiation eye gear when you go in a remote.
Astronomical event in human history. A total solar eclipse will cross the United States of America from coast to coast. Now, a total eclipse, this is what happens when the moon completely covers. Well, this is the lighter part of the moon.
Oh, it looks like we're there you are.
Apparently.
We're having a bit of technical difficulties, Julie. Can you just repeat the last thing you said? Maybe stand still?
Oh, yeah.
It is taking to hold it. Oh, wait. Made a mistake. See now this is live. From last 2 hours, 50 minutes it's happening. From 2 o'clock it's happening. Of course, it will take for another 6 o'clock 10 minutes in Indian Standard Time. Okay, if there are any queries, okay, this is the thing where the music is coming. My God. This is how the sun is there. Sun is not so beautiful as you like. See. That will come back, not an issue. Yeah, if there are any queries, we'll see. Otherwise, just watch the what we can call the eclipse. Now I'll stop sharing the screen. If there are any queries, I can make an attempt to clarify you. Any doubts, Aisha? Ayesha is not on audio. Okay, she might have entered into the laptop. Sorry, desktop. Arpita?
No, sir.
Okay, Shalini? If no doubts, just watch. May not be through direct eye. Okay?
Sir?
Yeah, please, Suma.
Sir, Mars allu kuda now eclipse agutta, sir?
Agutta. That is the eclipse of Mars for what actually? Mars means you are expecting fine. There should be an obstacle in between. Obstacle has to come. For example, I told you yesterday, you just bring your finger, any one finger before your eye. Adjust the distance between your eye and the source of light with your finger. Some point you cannot see entire source. That is the ideal distance. If you keep little bit away, or you can take a 1 rupee coin or any coin of that kind, put in front of one of your eye, close one eye and close another eye with your coin actually. At some known distance, it should be the exact distance. That distance is there. Call it as the what you can call arc angle. They can call arc angle. They can call. It will happen if moon moves few kilometers away from us, few hundreds of kilometers away from us, or if it comes few hundred kilometers of before towards our earth actually, few hundred means few thousands you can expect. Okay, then the eclipses may be a tip task. Okay, or if earth moves little bit ahead of us right now we are about 150 million kilometers. Assume that it is about 160 million kilometers. Just make a drawing in such a way that it takes this shape of an 10 centimeter diameter, some 2 centimeter diameter circle, and keep another diameter, another circle at a distance of about 10 centimeter. Assume that the 10 centimeter diameter circle also you can write. Okay, one is 2 centimeter diameter, another one is about 1 centimeter diameter, which are separated by 10 centimeter. Okay, draw the line. Otherwise, I will show you in one case here. Only one I will do. Where is that? Where is that? What I have to do? Can you see this right now? Hello?
No, sir.
Oh,
No, sir.
It is not shared. Huh? Somewhere it is missing. I put it for share. Right now?
Yes, sir.
Okay. Only this part. Okay. See, this is the earth. Maybe exaggerated, doesn't matter. This left side is the sun. What I want to say that start line, this line. This line has to meet the smaller circle at that unknown point. This has to meet this circle at another point actually. Okay. This is the total amount of the solar radiation falling on earth actually on a given time, particularly during daytime. Bring any obstacle where it has to block. Okay, for example, if I am bringing here, draw this line passing through straight away through moon, and it has to hit the circle point actually. This is known as the umbra. If not, if it intersects well before, why it has to intersect well before? There is no other chance to intersect before. Why? Because if it is passing through from, assume that this is the maximum extent it can pass through, let us draw a tangent here. This tangent has to meet the surface of the sun. This tangent has to meet the surface of the sun. Then you extend it. That should also be because of the penumbra. But if the sharp edge comes, whatever it is touching, that should be the umbra. Change this distance. Assume that somewhere moon should be here. Maybe moon should be here. Moon should be here. If the moon goes near to the sun, you may not get it at all. If the size of the earth and moon, they are one and the same thing, certainly it should have the eclipse for longer duration. Or length of the shadow will also be for the longer distance they can call. You can expect the eclipses on Mars. Thing is that Mars itself is already at a distance of about 225 million kilometers away from the sun, and some obstacle should come in between. For example, here, instead of moon, satellites are also revolving around the earth, some artificial satellites. Can we get to the shadow of the satellites on the earth? Yes or no? Certainly it must be, but that's very small shadow. Instead of satellites you forget it about. Can we get the shadow of an helicopter which is moving in the sky? Yeah, if you cleanly observe, if you are a keen observer, okay, particularly if it is while taking it off, not at the greater height of about 10 or 12 kilometers of that kind, while doing it is taking it off, certainly you will get R. Don't worry. Just take a notebook, let it be a source from the top your light, okay. Keep the notebook near to the floor, you can expect the shadow of the book. Raise the height from the floor. Can you expect up to what extent you can expect the shadow of the book? Maybe where appreciable distance they can call. Beyond that limit, you can't expect like that actually. Even though the moon is about 7,000 kilometer diameter, it can cast the shadow only of the order of about few meters for a duration of about maximum duration of about 7 minutes. Maximum duration of 7 minutes of the solar eclipse. Okay, but Earth being the larger one, it can cast almost about 2 hours. That's what I want to say. Any other query, Suma? Is it okay?
Okay, sir. Thank you, sir.
Okay, thank you. Okay, if not, I will stop. Anybody from Chintamani? Nobody is from Chintamani or nearby Chintamani? They are organizing 5-day program from 4 o'clock to 6 o'clock every day, where they are having seminars by the students. and I am attending that one as one of the participants. Okay, if you allow me, I will join that program. Is it okay? Thank you. We will meet tomorrow by the same time. I'll end the class now.